guys, so in this video we're going to introduce you to how to find out whether a series converges or diverges through the divergence test. So the first thing I will make is you should make a quick note that the divergence test is usually the first test performed whether in order to determine the convergence or divergence of any series. And why is that? That's because the divergence test is usually the fastest test. Because if you can test a divergence right away, then you don't need to do any other series tests. Note this will not always be the case, but whenever you look at a series, the first test you should always try is the divergence test. So here we have an example of a series 6n raised to the second power minus 37 divided by 5n squared minus 9. So the first step we're going to do is we're simply just going to identify a sub n. So identify all the variables, which is what we're going to do right here. So the variables that need to be identified for this particular problem would be a sub n. So our a sub n is just simply equal to 6n squared minus 37 divided by 5n squared minus 9. So now that we know what our a sub n is, the next step is we're going to go ahead and compute the limit using this formula right here as the limit of a sub n as the limit of n approaches infinity. We're going to take the limit of this. So without further ado, for step 2, we're simply just taking the limit L, and then based off what L is, we can tell whether the series converges or diverges by using the divergence test conditions. So the limit as 6n squared minus 37 divided by 5n squared minus 9. The limit as n approaches infinity. So in this case, noticing that they have the same exponent, we're going to go ahead and apply L'Hopital's rule, which I will note as this, which is a proper mathematical way to note this. So in doing so, we're going to take the derivative of the numerator and the denominator, the top function and the bottom function. So in this case, the derivative of the numerator, once we compute it, is 12n divided by the derivative of the bottom function would simply be 10n. And since we have n, we're going to go and apply L'Hopital a second time. So in doing so, we take the limit as n approaches infinity of 12n over 10n, and again we apply L'Hopital's rule, and in doing so we get 6 over 5, and this is equal to our limit. So now for step 3, now that we have L, is we're going to test the divergence, or we're going to apply better said, we're going to apply the divergence test conditions. So in doing so, what was our L? Our L came out to be 6/5. And now what are the divergence test conditions? So we go to our divergence test conditions, which I'll go ahead and just highlight them. All right here. So since L does not equal 0, then we can confirm that this series diverges. So basically, all we need to look for is what does our L equal? And in this case, L is equal to 6/5, which is not equal to 0. And that's honestly all we needed. And since this is not equal to 0, we can then say that this series diverges. And that's how you apply the divergence test. So in reality, this test is very short, very straightforward. So that's why it's the first go-to test, because when you apply it, if you already can tell it diverges, you don't need to apply any other series. But that's how you would apply the divergence test. Thank you for watching. I hope that was helpful. Hello guys, so in this example, we're gonna learn how to test out the divergence test to test whether a series converges or diverges. So the question is asking us, does this series converge or diverge? So quickly, I want you to make a note of this. So I put it in red. The divergence test is usually the first test performed in order to determine the convergence or divergence of any series. Why? Because it's quick. It's quick. So if you can test the divergence of a series straight off the divergence test, then there's no need to do other series tests. It saves you a lot of time. So we have a series right here, 6n divided by n cubed, and we want to see if this series converges or diverges. So the first thing we're going to do is simply just identify a sub n. So identify all the variables, and in this case, our variable is a sub n. So, and our a sub n is equal to 6n divided by n cubed. So now that we have that, the next step is step 2 is we're going to go ahead and take the limit of a sub n. We're going to take the limit and we're going to call it L. So in doing so, in order to take this limit, we apply this formula right here. The limit as n approaches infinity of a sub n. And that's why it's important to identify what your a sub n is. So the limit as n approaches infinity of 6n divided by n cubed. So right away, the first step I'm going to apply is I'm going to go ahead and apply L'Hopital's rule to take the derivative of the top and the bottom of the function, since it has the form of L'Hopital. So in doing so, when we apply L'Hopital's rule, taking the derivative of the top and the bottom, the limit as n approaches infinity, the derivative of 6n is just 6. The derivative of n cubed would be 3n squared. So whenever we simplify this, we get 2 divided by n squared. And then from here, what we can do is we can just go ahead and simply plug in n. So the limit as n approaches infinity of 2 divided by infinity squared is equal to 2 over infinity. And anytime you have a constant over infinity, 2 over infinity, that's just going to be equal to 0. So in this case, the limit L came out to be equal to 0. So L is equal to 0. So this is our limit. So now what we do is we go back to the conditions of the divergence test. So the conditions of the divergence test are right here. And we're going to go and just scroll down here. Step 3 is to apply the divergence test conditions. So in doing so, by applying the divergence test conditions, we clearly see that L is equal to 0. L is equal to 0. And since L is equal to 0, what this does tell us is that this method is inconclusive. So inconclusive. So that's our final answer. And basically what we have to do now is we have to find another method, which we're not going to go over in this video because there's plenty of other methods that I'm going to teach you in other videos of how to find this particular integral or this particular series. But all we know is that divergence test failed, inconclusive. So we can test divergence or convergence using another method, but for this particular video, not this method. So in quick retrospect, what did we do? In step 1, all we did was just identify the variable, or identify the variables, which in this case was a sub n. A sub n was 6n divided by n cubed. Then in step 2, what we did was we did all the arithmetic and find out what L would be by computing its derivative, applying L'Hopital's rule. And then in step 3, we just applied the divergence test conditions, which when L equals 0, the test is inconclusive, and we can test convergence or divergence using another method, but not this method. So that's why you always do it first, because the divergence test is the fastest test. So that's why we always perform it first. So always make sure before every time you have a series, if it passes the divergence test, then don't worry about doing any other series tests. Thank you for watching. I hope that was helpful.